Hi guys, welcome to another episode of MrLopezClasses.com. This is the chapter 7 of our marine diesel engines class. This is the chapter 7 dedicated to the cylinder block, the block of the cylinder in diesel engines. This is another critical part of a diesel engine. It's the heavy part of the diesel engines. The diesel engines are famous because they are too big. Why the diesel engines are too big in comparison with gasoline engines? Because you remember the quality of the detonation in diesel engine in comparison with gasoline is 100 times bigger than the power of the detonation in gasoline engines. For that reason, the thickness of the walls, the heavy of the material is higher in diesel engines in comparison with gasoline engines. And yes, it's possible that the block be cracked, be broken. Yes, it's possible. It's possible, especially in marine applications. Remember, we are going to talk later about that. There are two types of refrigerations in marine diesel engines. One type is with the circulation of salt water internally in the block and the head. This is one type. It's not common. Every day is less common. And the other one is with the internal circulation of coolant. But the coolant outside of the block in a heat exchanger is refrigerated, decrease the temperature, and return into the block with low temperature. This is the most common. But there are both of them. And yes, it's possible that the block be broken, be cracked, and it's possible that coolant or salt water enter in the combustion chamber and produce catastrophic consequences. You remember in previous episodes, I explained that if coolant enter in the combustion chamber when the engine is running, probably the engine continue running, but the engine produce too much vapor, and the color of that vapor is white smoke. And however, if salt water enter in the combustion chamber, immediately the engine block, hydro lock. This is the two situations when humidity enter in the combustion chamber. Yeah, one of the possibilities is because the cylinder walls are cracked, and with the temperature the crack expand and the water enter in the combustion chamber. Yeah, this is possible. Okay, this episode is divided in two sections. The first section is dedicated to the different type of cylinders, liners. The different type of cylinder liner, we are going to study those liners. And the second part of the episode is dedicated to the restoration of a block if suddenly salt water enter in one cylinder or two cylinders. Yes, it's possible recover the block, the cylinder. It's possible repair the cylinder working inside of the engine room. This is very possible. It's very common, and I am going to explain the procedure step by step in order to do that job. Let me check quickly the theory related with the cylinder block according with our book. The most important part is remember the parts of the block. Remember how important are the parts of the block. Remember that internally in the block have special cavities for the movement of the coolant and special cavities for the movement of the oil. And in one section of the block and the head, it's possible that the coolant be mixed with the oil. That area is the area in between both of them, in between the head and the block, the area of the head gasket. If the head gasket is cracked, the coolant can pass to the oil cavities or vice versa, and the oil at the end of the day become milky oil, become emulsified with water. Yes, it's because the cavities, those are the cavities for the push rods, but you have cavities for the coolant. You see the coolant cavities, and you have cavities for the oil cavities like this. And look, this is coolant and this is oil. If the head gasket is broken in this area, the coolant is mixed with the oil. is very common problem, especially in that part. You remember in the previous chapter when we studied the head gasket, this is the most critical area, exactly this area in between both cylinders. Okay, remember we have in the majority of the diesel engine the camshaft installed in the block, and we have the crankshaft installed. If you check in the back of the engine, if you have a bottom view of the block, we have the camshaft here, and we have the crankshaft here. Yeah, they are pretty close. They are pretty close because if you check in front, you remember the gear of the cam and the gear of the crank, they engage together. They are pretty close and they work together. Remember I explained in previous episode, crankshaft and camshaft are perfect brothers. They are brothers, and the camshaft sensor and the crankshaft sensor, they work together in order to send and receive information with the computer in order to keep the engine running in good condition. We are going to study later the codes related with the camshaft and crankshaft position sensor errors. We are going to study those codes, the consequence and the solution in each case. Remember the blocks, the configuration of the blocks in the majority of the diesel engines are in inline, six cylinder inline, 8 cylinders inline, 4 cylinders inline, 3 cylinders inline in small generators, a small diesel engine for sailboats. We found the 3 cylinders inline, and in V configuration, it's very common, 6 cylinders in V, 8 cylinders, 10 cylinders, 12 cylinders, 16 cylinders. Detroit Diesel, NTU have a lot of engines, V10, V12, V16. Okay, those are the most common configurations, and don't forget that internally in between the block and the head, oil and coolant is circulated in separated cavities, but the oil circulates in order to keep the engine properly lubricated. The next coming chapters we are going to talk about the lubrication system, very important. And after the chapter 10 we are going to start with the cooling system, and we are going to study the path of the salt water and the path of the coolant, and we are going to analyze where is the problem. The problem is in the coolant side, the problem is in the salt water side, and we are going to solve it millions of problems related with high temperature, the most common problem in diesel engine, high temperature. All right, my friends, we are going to continue quickly. Those are the cavities. This is the cavity for coolant, and this is an example of the cavities for oil, for motor oil, for engine oil. All right, and we are going to start to study the different type of cylinder liners, the different type of cylinders. And basically there are two type of cylinders, two type of cylinder liners. The most common in marine application is the wet cylinder, wet cylinders, wet liners. The second one is the dry liners. There are two type of liners, dry or permanent, and wet or removable. You can remove the wet liners and you can replace with simple tools. We are going to explain right now the procedure to remove wet liners and the procedure to remove dry liners. Really the dry liners can be removed in a special machine shop. They have the equipment I'm going to explain right now in order to remove those liners. In general terms, if you have dry liners or permanent liners and you have problem with the liners, you can solve it inside of the engine room with the method that I am going to explain today. But if this method is not the solution, you need to remove the block out of the engine room and send into the machine shop. And in the second type of liners, the wet liners, yes, you can remove with a simple tool that I have here, and I am going to explain right now. And you can replace for new sleeves, new liners, and you have your engine right now again in a standard like new one, and you can rebuild the engine inside of the engine room if you are clean, if you are professional, if you are organized. That's the secret. Be organized in order to repair properly diesel engines. Okay, in that case I am going to explain quickly the procedure to replace the liners, but let me explain before the different type of liners, the wet and the dry liners. If you check in this picture, the dry liners are solid pieces of metal inserted in the block. In other words, the coolant is separated from the liner. The liner is the blue one. In the wet liners, the liner is in permanent contact with the coolant. This is the coolant, and the liner is in permanent contact. In the wet liners, the coolant is surrounding the liner all the time. Yes, the wet liners are more efficient in terms of administration of temperature, because the cylinder wall stay with good temperature, with good operational temperature, and run better, of course. Let me I explain something before we continue. If you remember, in gasoline engines is, in general terms, is better keep the engine at lower temperature as possible. In diesel engines, it's better try to run the engines in the limit of the temperature, in the limit of the range. In other words, the diesel engines have better efficiency if the engines are running in the top of the range of temperature. We are going to study later that. This is very, very important. Okay, my friends, those are the different type of liners, and we are going to check the dry liners or permanent liners. Dry liners are pressed into the block and do not come in direct contact with the coolant, because they enter in the material of the block. Normally is cast iron. The material of the liner is a special hard steel with a heat treatment in the surface. It's a special steel. It's expensive steel. It's too much hard to replace, because require preheat the block and ice down the sleeve. This is the process. They have a special equipment that preheat the block, expand the block, and they have the sleeves, the liners, in a freezer. The liners are contract. When they remove the liner from the freezer and enter into the block, they expand and keep the whole fit. All right, those are the dry sleeves. The only way to replace those sleeves, those liners, is on the machine shop. In that case, you need to remove the block, remove the engine out, and send into the machine shop. In other words, the main engines, the principal engines in the majority of the boats, pleasure boats, mega yachts, and super yachts, they are with the wet sleeves in order to replace the engines inside of the engine room. The dry sleeves are very common in generators. A small and medium generator that is possible remove the generator completely out and send into the machine shop to rebuild the block. But in big engines, the big blocks, the liners are wet liners or removable liners. Okay, this is the typical dry liner. You can see the difference between the material, the metal of the liners, hard steel, and you can see the material or cast iron of the block. Yeah, you see the difference in between the material, and you see the thickness. Right now we are going to talk about that. When the engine is new one, the diameter, the bore of the cylinder is standard. When the engine is new one. When the engine is new one, let me explain here, a cylinder bore, when the engine is new one, you say that the bore of the cylinder is standard. When you hunt the cylinders, when you send the block to the machine shop and they hunt, the first time they remove 0.020 inches. And you say that my block right now is plus 20. When you send again the block to the machine shop to bore again, they remove 0.0 other 0.020, and right now the block is 0.040 inches. And you say, oh, my block is plus 40. When the block of that engine is plus 40, is in the limit. It's not possible bore again that cylinder. You need probably replace the sleeves for new ones in order to return the engine to standard. If the liners are dry liners, it's too expensive, and the people prefer replace the block for a new block. If the liners are wet liners, always when you replace the liners, your engine right now is standard again, standard all the time, because you replace always the cylinder liners for standard liners. It's clear? In other words, the dimensions of the liners are standard, plus 20 or plus 40. That's the most common denomination. And it's exactly the same for the piston rings. You can order piston rings, we are going to talk later, standards, plus 20, plus 40. In some manufacturers, they fabricate piston rings standards, plus 10, plus 20, and plus 40. That depends on the manufacturer. And exactly the same with the bearings on the crankshaft. You have standard bearings plus 20, and bearings plus 40. And yes, normally when the piston rings are standards, the idea is that the bearings be standards and the piston rings standards, all of them in the same dimension. The bore of my cylinder is plus 20, the piston rings should be plus 20, and the bearing should be plus 20. Exactly the same, all of them. Piston rings, both of the cylinders, and bearings, plain bearings. Now we are going to continue with the process to remove the liners and replace the liners. We are going to follow step by step the process, and I am going to explain in each step additional recommendation. Let me explain something before we start with the removal of the liners. The liners, they have normally in the bottom 3 groups for the administration of the coolant. The coolant is located in this area, and in the bottom is the oil pan. For that reason, there are 3 O-rings. The first one is normally green color in contact with the coolant. The middle one is orange, and the bottom one is a black color in contact with the oil. Now we are going to start to talk about this. And normally in some engines there are a cavity on top for circulation of coolant in order to keep the combustion chamber properly refrigerated. We are going to check in this video the procedure to check the measurements of the cylinder liners, the dimension of the cylinder liners, and the procedure to insert and remove the liners appropriately. Okay, we are going to start right now with the video. In order to remove the liners, we are going to remove the pistons with connecting rods. The procedure to remove the pistons and connecting rod is basically from the bottom. We need to remove the oil pan in order to push out the pistons. Of course, in some boats it's difficult because you are working in the engine room and the space in between the oil pan and the bilge of the boat is a little. You need a lot of work. You need to lift the engine a little with special frames. You need to lift the engine, and when the engine is lifted, you need to block the engine and remove the oil pan carefully and work from the bottom, pushing the pistons out. This is a big project. For that reason, you need to calculate everything. Calculate the tools that you need, calculate the time that you need, the people involved on the project. Be careful because in the engine room, in some cases only 2 people can work together at the same time, depending on the space of the engine room. But you need to take and analyze all the considerations around a project of this type. Okay, in this particular example, the first step is the removal of the oil pan. We are going to remove the oil pan carefully, and we are going right now to remove the connecting rods. The connecting rods. Remember, this project is specific. The project when one piston, one cylinder receive salt water. and we are going to try to recover the engine. We are going to try to repair the engine. We are going to repair one cylinder or two if it's necessary, working inside of the engine room. This is the most important part. Yeah. For that reason, we are going to be focused in the removal of one piston, one connecting rod, and the reparation of one cylinder in particular. This is the procedure exactly to solve that situation. Okay, and we are going to remove the end caps of the connecting rod carefully. And when the end caps of the connecting rods are out, we are going to verify the condition. We are going to verify carefully the condition of the bearings. We are going to verify if the bearings are destroyed, if there are water in between the bearings and the clamping. And with a piece of wood, we are going to push slowly the piston, and in the other side, we are going to receive the piston. We are going to receive the piston carefully. We are going to receive the piston. Okay. And now we have access in the other side to remove the piston with normally is other person in the other side of the block receiving the piston. And now we have the piston with the connecting rod out, and we are going to introduce the tool. This is the tool that we are going to use. And if you check the tool have two long legs, and at the end of the legs they have two small protrusions. Those small pieces of metal at the end of the legs enter in the bottom of the sleeves and expanded, and with the bolt in the center of the tool, you pull the sleeve out. Right now we are going to check the procedure to do that. The first step is this is a small demonstration with my tool and with my cylinder liner, and after that we are going to continue with pictures from other instructors that I took those pictures. Thank you for the instructors, thank you very much. And I am going to explain the procedure step by step, slide by slide. Alright, this is the tool. We introduce the tool carefully, and now the pieces of metal at the end are exactly over there, and now those big metals are on the block. My hands are the block, and now when you turn it this one, the sleeve is going out. Okay, right now the technician is introducing the tool inside of the liners and the block, and locating exactly. And now with the wrench, turn it. With the wrench, turn it, and the liner is going out slowly, more out. And right now the liners pass exactly. This is the position. This is the moment when you remove the liner completely, and you see in this particular example, the liner only have 2 O-rings in the bottom. Normally, the majority, they have 3 O-rings in the bottom. The top one normally is green color, the middle one is orange, and the bottom one is black. But in this particular case, the manufacturer use the same color for both O-rings. Normally, the O-rings, they have labels indicating that the top one is coolant O-ring and the bottom one is oil O-ring. Don't forget, quiz question. The top one in contact with the gray area, remember the gray area is surrounded by coolant directly. For that reason, that coolant is critical. Let me explain something, my friends. In this moment, we introduce another possibility for mixture of coolant with oil. You remember until today the possibility that we have for a mixture of coolant and oil? Yes, one possibility is on the head gasket. If the head gasket is cracked, yeah, exactly, in the middle, in between both cylinders, when the head gasket is broken, the oil can be mixed with the coolant. That's one possibility. Other possibility, yes, is if the head is broken or cracked. When the temperature increase, the crack expand and the coolant penetrate the combustion chamber, and finally the oil is mixed with coolant. Other possibility is if the block, if the cylinder, if the liner is cracked, Oh, the liner is surrounded by coolant. The gray area on the gray area on the cylinder is surrounded by coolant. If the liner is cracked, the coolant penetrates and enters in the combustion chamber. And now we are going to introduce the fourth chance to intrusion of or mixing of coolant with the oil. Is because the O-rings in the bottom of the liners are broken, and the coolant from top of the liner goes down and mixes with the oil. Yeah, there are 4 possibilities for oil mixed with coolant until this moment. Probably later we found it other additional. Okay, and now we are going to check the procedure to install the liner on the block. A new liner normally. Remember, when you replace the liners, you have the engine in standard measurements. It's easy because right now the engine once again is standard, and you can replace the piston and the piston rings for standard measurements. Okay, right now we are going to do the procedure to put in back the liner slowly, and we are going to check each step. Okay, this is the liner installation. The first step is the most important step, is verify the dimension of the new liner and check the comparison with the old liner, especially in those dimensions. We are going to check the total length. We are going to check the thickness of the shoulder. We are going to check this thickness, and we are going to check if the grooves are according with the O-rings. We are going to verify this measurement, these measurements, and the total measurement. I am going to explain right now why we need to verify those measurements. Okay, the first one is check the internal diameter in order to verify if it's according with the piston that I have in my hands. Okay, the thickness of the shoulder, very, very important, according with the thickness on the block. All right, exactly. And this dimension, the external of the shoulder, with the dimension exactly in the block. This is very important. This is very important. Let me explain what happened with this, my friends. If the shoulder, if the protrusion is a little smaller with the space that you have on the block, when the piston is moving up and down, probably the sleeve will be moving up and down. This is not good. Why? Because remember, the sleeve is surrounded by coolant. If the sleeve is moving at high speed up and down with coolant around, it's possible that small bubbles of air in the coolant, because the temperature and the movement of the liner increase the diameter of the bubbles. And if the diameter of the bubbles increase because the pressure increase, those bubbles explode against the cylinder wall and produce cavitation and destroy the cylinder wall, like the picture that you have on the screen right now. This is critical. We are going to talk later about that in the chapter dedicated to coolant systems. And also we are going to talk about that specific situation in our book of corrosion. We have one chapter dedicated to that phenomenon, the phenomenon of cavitation, because the bubbles on the coolant explode against the external walls of the cylinder liner if the cylinder liner is not exactly the liner recommended in dimensions. For that reason, checking the dimensions is critical. Okay, and right now we are going to check the total length of the cylinder. This is very important in order to avoid that the liner, this is very important in order to avoid that the liner touch this element. This element is the oil jets. The oil jets are special nozzles that spray oil from the bottom of the cylinder. This is the cylinder, the liner, the piston is here, and in the bottom are located the oil jets. The oil jets are connected with the internal cavities of the oil at high pressure, 60 psi. Okay, those oil jets spray oil in the bottom of the cylinder in order to keep the cylinder walls internally in between the piston and the cylinder wall properly lubricated. We are going to talk later in the chapter about the lubrication, about the oil jets. But in this moment, you need to verify that the total length of the liner don't touch the oil jets. All right. This is very important. For that reason, the total length is another important dimension in order to verify and avoid that the cylinder liner touch the oil jets. Okay, after those, now we are going to verify if the groups are according with the dimension of the O-rings. Those are the O-rings. If you check on the picture, we have 3 O-rings. The black one, the oil controller, should be located in the bottom. The orange is intermediate, is located in the middle one, and the top one normally is marked with the label coolant, is located on top in order to control the coolant. All right, if those O-rings are not appropriated in diameter or in material, the O-rings will be eroded and the coolant pass and mix it with the oil. That's critical. Okay, for that reason you need order original O-rings, no aftermarket, original O-rings, and verify that the thickness is the appropriate. Immediately you install the O-rings on the cylinder. You install the O-rings here, the 3 O-rings. You need to cover it with grease and added grease additionally inside on the block. In the moment that we introduce the liners, we need that the grease help to enter the liner and help to protect the O-rings, the material of the O-rings. Alright, right now we are going to check that procedure. Okay, now we have the O-rings. We verify that the O-rings are properly installed. Okay, those are the O-rings. We have, in this particular example, this manufacturer only used 2 O-rings in the bottom. The top one is in contact with coolant, and the bottom one is in contact with oil. And if you check in that picture, the gray area is an area in permanent contact with coolant. The coolant is surrounding that area. On top of the piston is a big groove. In that groove, let me show it right now. The coolant in the middle. Okay, and now on top of the cylinder liner, we have an extra groove. The extra groove, the thicker is bigger, is in contact with that hole, the hole that I am marking on the slide. In that hole you have circulation of coolant. In other words, coolant is circulating around that circle, that cylindrical area, in order to keep the temperature of the combustion chamber appropriated at low temperature. Some manufacturers, they have circulation of coolant in that area in order to keep the temperature of the combustion chamber at the appropriated temperature recommended by the manufacturer. Okay, this is a very important. Not all the liners have that one. Okay, this is the procedure to introduce the first step. A lot of grease in the bottom, and with your hands you feel that the O-rings enter. You introduce with your hand until one point you feel that O-ring number 1 pass, you feel that the second one pass, and you feel that the third one enter. In that moment you have 2 possibilities to introduce the rest of the liners. With a plastic hammer, carefully, with a piece of wood and the hammer, or with a special tool if you have the tool specific for that engine. The tool is basically a triangle, and you bolted the ends of the corners of the triangle in the holes designed for the head bolts, but this is supposed a special tool designed for that specific manufacturer. I have both pictures, and I want to show to you that procedure. Okay, in this moment the technician is trying to introduce to passing the 3 O-rings. This is with the hammer. with the hammer, bronze hammer in one side and plastic hammer in the other one. And this is with the tool. This is the tool. You locate the tool exactly on the holes, and you bolt it with the head bolts, exactly with the head bolts. And now you turn it, the central bolt, and you push down the sleeve. Yeah, exactly. Right now the sleeve is completely down, and you can feel with your hands, with your fingers, that the cylinder liner enters perfect. You clean the area around. You try to move it with your hands in order to verify that you don't have lateral play, and you continue with the next cylinder if you are replacing all the liners. If you are replacing only one liner because that the engine have problems only in one cylinder, this is the process. It's not complicated. The only that you need is the extractor in order to remove the liner. That extractor is universal. You can use that extractor in any type of diesel engine, and you can buy that extractor in any automotive shop. Extractor for cylinder liners. You check in Amazon and you found that the extractor is not expensive. Alright, be careful with the O-rings, order the appropriate O-rings, be careful with the grease, be careful with the dimensions, check the dimensions before you install the liner, and check that the surface is completely flat when you finish the installation of the liner. Alright, this is the procedure, and right now I am going to explain the procedure. In some cases the liner is not removable, it's not possible to replace the liner. It's a dry liner. In other words, the liner is inserted in the block. What is the procedure? The people in the machine shop expand with high temperature the block, and they put the liner, the dry liner in a freezer. The liner is contract. They introduce, and after that expand, and the metal stays permanent over there. In other words, the dry liners are not possible be removed by yours inside of the engine room. You need to remove the block and send to the machine shop in order to bore the cylinder for a big diameter, plus 20, plus 40, right? Okay, in this project, I am going to explain to you, and in the next part of the episode, I'm going to explain to you the procedure to hone the cylinder by yourself inside of the engine room using the drill and using the honing tool. And this is the procedure. Okay guys, now we are going to do a wonderful project. What is the project? In my boat, my engine or my generator have a problem in one cylinder. Salt water enter in one cylinder or two. But I found that the problem, and immediately I found that the problem, I removed the injectors, and I found that where is located the water, the salt water in the cylinder. I found that the problem was in cylinder number 1, for example. Okay, and now I am going to try to recover the engine easily. What is the procedure to try to recover the engine easily? I need verify if it's possible move the crankshaft. I am going to install a big socket at the end of the harmonic balancer, and with a pipe and an extension I try to move it. In some cases it's not possible. It's not possible move the piston because the piston is seized with the cylinder. Normally, according with my experience, I added mystery oil through the hole. I added mystery oil through the hole where the injector was located. I added the mystery oil over there, and I let the mystery oil 12 hours inside of the area. Of course, before of that, I removed the water. I suction the water, and right now the area is dry, and I introduce the mystery oil a little. It's a little amount, only to cover the face of the piston, the top of the piston. And I let 12 hours. And the next day, with the boroscope, with the camera, I check inside of the hole. when I finish, I let 12 hours, and the next day I try to check with the camera, and I try to move it again with the ply bar, the piston, and I verify with the camera if the piston is moving or not. Yeah, I take the picture. This is an important picture. In some cases, when I took that picture with my boroscope, I sent the picture to the customer, and I said, "Hey, this is the situation in your piston, in your engine. We need to remove the head in order to repair that cylinder. I need your approval," and normally the customer approved the job. Okay, my friend, this is very important. Try to buy the boroscope in order to introduce the camera and take the picture exactly the situation. All right. Right now, you take the decision. I need to remove the head. Okay, we are going to remove the head after this decision. With the boroscope, we remove the head, and right now we remove the head, and right now we have access to the cylinder corroded. This is the cylinder fully corroded. Okay, right now start the process. What is the idea? I need put out the piston with connecting rod. What is the procedure? Is from the bottom. From the bottom, you remember, I need remove the caps, and I need with the piece of wood push the piston out. Okay, but there are a lot of corrosion in the cylinder walls. I need with sandpaper, with my hands, with a wire wheel, remove the excess of corrosion. I am going to remove the excess of corrosion on the cylinder carefully with sandpaper, a lot of sandpaper, and I clean periodically with a mineral spirit, with wire wheel, with sandpaper. I clean periodically. I remove more. I clean periodically with a mystery oil, probably with a mineral spirit is enough, and we clean the area, and we added more oil around the area. And right now I think that because I moved the piston before, you remember, and right now I verify that the piston is going up and down. Okay, this is an indication that I can remove the piston easily with a piece of wood from the bottom. Okay, right now I am ready to turn it, or I am ready to remove right now the oil pan in order to get access to the connecting rod. Yeah, this is the first step. We are going to remove the oil pan carefully. All right, and now exactly, you remove the gasket carefully, mark the bolts, put the bolts in a plastic bag, and now you have access to the connecting rod that you need to remove it. Once again, mystery oil, in order to remove easily the connecting rod. Remember, be careful with the connecting rod. The connecting rod have only one position. Never switch the position of the connecting rod, because after that, when you try to put in back the connecting rod with the cap in a switch position, the engine is not turning 60 degrees and stop immediately. Be careful with that. The connecting rod only have one position, and you need to mark that position. All right. Okay. And now this is the moment to verify the condition of the bearings. This is very important, because if the bearings are destroyed, you need, of course, if the bearings are destroyed, and if the metal in the surface of the crankshaft, in the surface of the crank pin, is dented, probably you need to remove the crankshaft completely and send the crankshaft to the machine shop. This is a critical moment. This is the moment where you verify the condition of the crankshaft. If you see that the crankshaft is in relative good conditions, the bearings are in relative good condition, like those bearings, you can continue with the project. You can replace only the bearings, only the piston, only the connecting rods in that cylinder, and you can recover the engine. Okay, in this particular case, the bearings are good. We are going to continue the project. We are going to, the bearings are the normal wear. and we are going to verify the marks on the connecting rod in order to put back the cap of the connecting rod exactly in this position. Exactly, they have marks, they have guides. Those guides are to avoid that you switch the position of the cap of the connecting rod. Okay, exactly, this is the position. Right now you put in a plastic bag, and now with a piece of wood you are ready to punch out the connecting rod. Okay, the piston is going out carefully with a piece of wood, and now in this moment the piston is going, the piston past the rings are open and out. Okay, and now this is the moment to analyze what happened. This is a critical moment to analyze the condition of the piston. I am going to verify if the piston rings are free. If the piston rings are not free, like a welded with the piston, probably we need replace piston. Not only the piston rings, we need to replace piston rings and piston for a new piston. Okay, and we are going to pass our fingers on the cylinder wall in order to verify if it's possible recover the cylinder wall with the equipment that I am going to explain right now. In this particular case, we have a lot of oxidation. We are going to try to clean that excessive amount of oxidation. Apparently, the rings in these particular engines are okay. We can move the piston rings with the hand. Yeah, the rings are okay. Probably we are going to use the same pistons. The piston loose in good condition and the cylinder wall loose in good condition. We are going to start with the honing of the cylinder. This is the procedure in order to hone the cylinder according with the condition of the deterioration. Okay, this is the next step. We are going to use a special tool in order to clean the cylinder, in order, like us, with sandpaper, and remove oxidation and recover the cylinder wall. There are two possibilities. One possibility is with a manual tool that you install in an electrical drill, or if you send the block to the machine shop. In the machine shop they have the industrial honing equipment in order to do the boring on the cylinder appropriately. Okay, we are going to start with the manual technique. We have two techniques. On the left side of your screen, you have the manual with the drill, and the second one on the right side is the industrial. This is the equipment. This is a cylinder honing equipment. All right. We are going to use. We are going to explain both of them, and we are going to verify the final product when you hone the cylinder. If the cylinder is in good condition, you can recover the engine, and you have engine for other 5 years or more if you service the engine appropriately. Okay, right now we are going to start quickly with the procedure using the manual cylinder block honing. You can buy the tool in any auto parts. You can buy in internet. The tool is not expensive. It's easy to use. This is the tool. The tool is coming in the plastic bucket. Piston cylinder hone, and those are the stones. Those stones are in different grades, like the sandpaper, and you can replace the stones on those tools for stones with a higher grade or lower grade according with the same nomenclature of the sandpaper. Okay, all right. And normally I use a middle grade, depending, and I finish with other tool for the polish at the end. Okay, this is the first step. We introduce the tool. We added periodically mineral spirit, and the idea is operate the drill at around 700-800 RPMs. In your book you have the recommendation about the RPMs. Check the book. And this is the procedure. We are going to spend like 15 minutes, 20 minutes in each cylinder. Where we do that process for 2-3 minutes. We remove the tool, clean. We remove the tool, and with a rack like this, with a rag impregnated with a mineral spirit. We clean the area of the piston, and we verify if it's properly polished. No, in this particular case, I think that we need a little more because there are marks of oxidation. But in general, the cylinder looks in good conditions. We repeat the procedure again, more mineral spirit, and we polish and polish and polish. If it's necessary, repeat this procedure 4 times, 5 times, no problem. The idea is try to recover the cylinder wall. Be careful when you move up and down the tool. Before you start to move the tool, I recommend that with the drill off, go down until the point where the crankshaft is located. One important thing, before you use this tool, remove the oil jet. Remove the oil jet in the bottom of the cylinder. If not, with the tool you destroy the oil jet. Please be careful with that. Remove the oil jet. Normally the oil jet is bolted with a couple of bolts or 1 bolt, like the picture that you have on the screen. You remove the oil jet and you verify how much I am going to move down my drill. It's like 1 inch. Okay, I am going to start the procedure moving no more than 1 inch down in order to avoid touch the crankshaft and destroy the stones on the tool and destroy the crankshaft in some cases. Be careful with that. Before you start, check how much I am going to move my drill down. And after that, you start with the process. In this particular case, I calculate ½ inch and I move ½ inch my tool, and I added periodically the mineral spirit, periodically, in order to complete the process properly. And now I remove the tool again, I clean the area, and I continue the process with the second tool that I am going to show to you right now. Okay, this is the process, and right now I clean and I am ready. I think this mark, this line, central line, is not a damage on the cylinder. This is normally the area where the material of the slip was welded. This is the welding area. This is not a problem on the cylinder, all right? This is part because this is a piece of material rolled and welded in that line, all right? This is that line, all right? Okay, and now I verify that the surface is good. Normally in this point I recommend bring a light and a magnifier, and with the magnifier analyze all the cylinder wall carefully and verify if you don't have any dents, any crack. If you see a small crack, you need to replace, you need to send the block to the machine shop. Okay, remember that process is recommended in general for dry liners. Because the wet liners are easy to replace. You replace the liner for a new liner. This method is good for dry liners, and is good to work inside of the engine room because you don't need to remove the block. But if you found a small crack on the cylinder wall, you need to send the block to the machine shop in order to repair the block. Okay? Alright, right now we are going to use the second tool. This is the second tool. This is a flexible brush. It's a brush with the balls at the end of a lead impregnated with sandpaper, with sand. Yeah, it's a brush of sand balls, and it's wonderful because with this tool you produce the final polish of the cylinder. And at the end, when you remove this tool and you clean the cylinder is like a mirror. It's perfect. You need to verify the pattern. The pattern, according with the book, should be 45 degrees. This is a good pattern in order to produce a good seal. Yeah, check the slide that you have right now. This is in your book. Alright, my friends, and right now I introduce the tool once again, mineral spirit, and I start to polish the cylinder. The last step is polish the cylinder with the tool. That's wonderful, because at the end of the day you have a great area completely polished. Okay, that's good. Right now, you use the same method. 1 time, 2 times, 3 times, or 4 minutes each time, and you clean in between each of these, and you verify that the area is properly polished, is properly glassed, according with the pattern 45 degrees. In this particular case, the cylinder is properly hung. The cylinder is in good condition, is not cracked, is in great condition. You see the pattern of exactly, and yes, we are going to recover this cylinder. We are going to clean the pistons, we are going to replace the piston rings, and we are going to put them back, the connecting rod, piston rings. We are going to replace the head gasket, and we are going to put it back the head. Okay, the head should be repaired with the method that we learned previously. We are going to remove the valve, we are going to seat the valves again, we are going to verify with gasoline that the valve seats properly. In other words, the head is in good condition. You need to check if the head is flat. If not, send to the machine shop and they cut it a little, and you replace the head gasket for a thicker head gasket, and right now you recover the engine and the engine is ready. The second method is with the industrial honic equipment. Those are the stones. The stones can be replaced for a stone of different grades, and the equipment is a mechanical equipment, is manipulated by hand. The technician operates. This is an example. Is constantly lubricated with a mixture in between water and mineral spirit, and the final product is perfect because it's controlled for machines, and some machines are robots controlled by circuit boards. I hope you enjoyed this video, and I hope that this video will be useful for use in the future, for use marine technician, marine engineers. Enjoy it.